Question: there are 2.1 pounds of carbon dioxide put into the air per kilowatt hour of energy produced by coal. You're calculating how much coal you would offset over a 25-year lifespan by installing each solar module. The IMP of the solar module is 8 amps and the VMP is 30 volts. If you install the PV in a location where it will average 1,333 kilowatt hours per kilowatt peak per year during the next 25 years, then how many pounds of CO2 will you prevent from going into the air for each solar module installed? Wow, that's an interesting one. So this is just a long focus question. So this might be one of those questions where you go, I'm going to just do this at the end, take an educated guess, flag it, and go back. Just because it's one of those types of questions, it's going to take a while unless you practiced up a ton. So while we're thinking of things here, let's see. So it wants to know per module. It gives us the IMP and the VMP. We can multiply 8 amps times 30 volts to get 240 watts. So our module would be 240 watts. I kind of think of that on the top of my head. Got to remember it's 25 years. Don't do the answer for years without multiplying by 25. That's how many kilowatt hours per kilowatt peak. And we're talking about pounds of CO2 in the air. Heavy stuff, that CO2. So let's break it down into steps here. First, what we're going to do is we are going to do, like I said, we're going to multiply IMP times VMP. Remember too, that this is not ISC and VOC. You're multiplying IMP times VMP. So 30 times 8, that's 240 watts. That's a 240 watt solar module. And when you're taking a test, they don't always have the most modern sizes of solar modules. So this is kind of a typical thing you might run into, seeing some wattage that seems a little bit not that much. But it's a nice, easy example for us to work with because 8 times 3 is 24. And there we have 8 times 30, 240 watt module. And then what we're going to do is we're going to convert the module's watts to kilowatts. So that's pretty easy. I mean, if you think about it, every PV module that you're going to be using has 3 digits in the watts, pretty much. And so you just put a decimal in front of it, which is moving the decimal 3 places to the left. It's also the same as dividing by 1,000. So 240 watt module is 0.24 kilowatts. That's what it is. And I was thinking, when is that going to change? When are we going to get to a point where we're going to have 4-digit modules? So that would be modules that are a kilowatt. And I remember a long time ago, they had these really big, huge modules, but it didn't take off. They were like the size of a garage door. But here I have a 700 watt module. That's kind of big. Modules are getting larger in size. It's not necessarily all about efficiency when you get these high wattage modules. And so same with a 240 watt module, you put the decimal in front of it, 0.24 kilowatts. A 70 watt module would be 0.7 kilowatts. So what we have here is the biggest one is 2465 millimeters. That's 2.465 meters. Pretty tall. Probably not going to have one person moving this thing around. And then the width is up to 1.3 meters wide. That is a big PV module. Whenever you see one that's got a lot of watts, it's a big module. So once again, we figured out that each module is 0.24 kilowatts. And we were given this factor. And so that is 1,333 kilowatt hours per kilowatt peak per year. Remember that number? And that number is how many kilowatt hours 1 kilowatt will make. Well, if we have a quarter of a kilowatt approximately, or 0.24 kilowatts, then we would be making about a quarter of this number in a year with a single PV module. And therefore, 1,333 kilowatt hours per kilowatt peak per year times 0.24 kilowatts per PV module gives us 320 kilowatt hours per year of production for each PV module. Little side note here, the average person pumps 255 pounds of CO2 into the atmosphere every week. Aren't humans great? It's more than our weight in CO2, or at least my weight. So then the next thing that we do is we figured out how much CO2 one module made in a year. And now we got to figure out what it's going to do in 25 years. And the question didn't talk anything about PV module degradation or anything like that. So we've got that 320, which was how much one module made. 25 years, multiply those together, and we get 8,000 kilowatt hours per module for 25 years. It's a lot of kilowatt hours for a module, but it's up there for a long time. So that just kind of reminds me that those broken microinverters that I need to deal with, I should get on it. So here we have something, just a little side note here, pounds of CO2 per serving. So we got beef way up there, a lot of CO2 going into that beef, could be like the diesel taking the cows around, stuff like that. And then even the cows breathing, all that good stuff. Then we could see down here far at the right, it's probably what Greta Thunberg's eating, or some potatoes and carrots. I like all this stuff, really. Guess I just like food. But we can see that beef is way high up there on the greenhouse gas scale. It's also another thing about cows is they make a lot of methane. That's natural gas. Essentially, it's cow farts, and people laugh about that, but it's significant, surprising. So then the next step of this question, because we figured out the kilowatt hours, but we need to convert that to pounds of CO2 that we will prevent from going into the air for each solar module installed. So now we get to go talk about the CO2. And I think we have a lot more than CO2 in that picture. So we've got 8,000 kilowatt hours in 25 years for a module times 2.1 pounds of CO2 per kilowatt hour equals 16,800 pounds of CO2. And you know what? Those PV systems can last longer than that. If you have a 25-year-old PV system that you don't want anymore, just give it to me. I will just use it to stop the CO2 from going into the atmosphere. I think it is silly to throw away perfectly good PV module. So while we're talking about all this stuff, we can see these patterns. So CO2 goes up slightly, very slightly, before sea level, and we have time here. And so these are thousands of years, 400,000 years. So if we come over here, 50,000 years, we were hanging out with other human species back then. So we can see that we've just come onto this scene very recently, and it's shooting straight up. CO2 is shooting straight up, and it's higher than it's ever been on this chart. So just something to think about. Help you relax and go to sleep at night, especially if you like seawater and hot temperatures. So there you have it. There is the CO2 question, and we are doing it too. The solar industry and the energy storage industry and the wind industry is growing very, very fast, and we're doing it. However, the Earth is already heating up at a very fast rate, and we can see that there's a lag here. It takes a while to catch up. So a little bit scary, but it's nice to know that you're in the industry where you're doing the right thing. And a lot of your customers will care about this kind of stuff too. People care about saving money and all that stuff, but there's a lot of them out there that also believe in this climate stuff.